What's up, YouTube? Mr. King coming live, not from the studio, but from the classroom. That's right, back and better than ever. Here are the questions of the day. Please pause the video and answer them now. Next, reminder, every dot is 1, and you always do them in 2s. So when you're counting stuff, count them like these dots will be 2, then this will be 4, then every bond, every one of these is 2 as well. So when you're counting, it goes 2, then 4, then 6, then 8, then 10, then 12. And that checks out because each oxygen has 6. So that's why this molecule works out. Because 2 oxygens, each ones have 6, so it will add up to 12. Okay, today we're going to continue our practice with covalent bonds. Here's some review on the rules. Per popular request, I did add the graphic back in, telling you how many valence electrons are in each group. That's the first step. You want to figure out how many valence electrons are in the molecule total. Then the next step, you put the central atom in the middle. Then you draw in single bonds from the central atom to the rest. Then you add whatever electrons you have left over as lone pairs. And then after you use all the electrons, if there still are elements that need 8, add in double, triple bonds, which you will have to do for a lot of these today. Here's the periodic table. We're going to do the first one together. It says use the periodic table to determine how many valence electrons each atom has and add them all together. Oxygen has blank valence electrons, and there are 3, so total is blank. So remember, this column has 8. This column has 7, and this column has 6. So oxygen is in this column, so oxygen has 6 valence electrons. And there are 3 oxygens, so 6 plus 6 plus 6, or 6 times 3, adds to 18. That's how many valence electrons we get with this molecule. Next step, put the central atom in the middle. They're all the same, so it doesn't matter. Pick one to go in the middle. Next, draw in single bonds from the central atom to the remaining atoms. So now you're just going to connect them with some single bonds. Remember, every single bond counts as 2. There's 2 valence electrons in these. So we've used 2 and 2 here, so that means we've used 4 valence electrons, and we have 18 total. So we have 18, we have 14 left over. So you're going to add those 14s, try and spread them out with these lone pairs. So I'm going to start adding the 14 back in 2s, and you will have to copy and paste because I did not give you enough dots. So I've used 6 so far, 8, 10, 12, 14. So I'm going to double check. I'm pretty sure I've used all 18 of the electrons that I was giving. 2, 4, 6, 8, 10, 12, 14, 16, 18. So I'm all out of electrons. I only got 18. But hopefully you notice there's a problem. This oxygen has 8. This oxygen has 2, 4, 6, 8. This oxygen has 2, 4, and 6. This oxygen is not full. This oxygen needs 2 more. So if you've used them all, but one of them is not complete, you have to go to step 5. Step 5 says, give every atom an octet by turning lone pairs to double or triple bonds as needed. So remember, when you're making a double bond, basically one of the elements nearby is going to give up its lone pair to make a double bond. So it's going to get rid of them, and it's going to make a double bond. Now they should all work out. This oxygen now has 2, 4, 6, and 8. This oxygen in the middle has 2, 4, 6, and 8. This oxygen has 2, 4, 6, 8. Now they all have 8, and I used all 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. That is ozone. Now you have everything you need. Make sure you just follow the steps carefully to draw O2, to draw N2, to draw ammonia, NH3. Whenever you think you're done, double check that they all have 8 at the end and that you used all of the electrons in step 1. Every dot is 1, but they always go together in 2s, and every bond is 2. Please pause the video now and try and finish them. And at the very end, I will go over nitrogen because this one is a little tricky. So remember, not all molecules need double bonds, but some do, and I really wanted to focus on those double and triple bonds today. So nitrogen is in this column, which means it has 5. So nitrogen has 5 valence electrons, and there are 2. So that leaves 10 total. And they're the same, so they both go in the middle, or they'll both be side by side. Then it says draw on single bonds from the central to the remaining atoms. So you're just going to connect them with 1. Okay. Then it says put in remaining electrons as lone pairs. So I have 10, and I just used 2. So that means that I have 8 left. And I'm going to spread them out. 2, 4, 6, 8. Okay. That means I just use all 10. 2, 4, 6, 8, 10. But hopefully you see there's a problem. This nitrogen and this nitrogen, neither of them are happy. They both have 6, but they want 8. So that means you have to do step 5. Turn the lone pairs into double or triple bonds. So this nitrogen will have to give up its lone pair to make a bond. Now, this nitrogen is happy. It has 2 up top, 2 below, and then 4 over here. So this one has 8. This one has 6. 2, 4, 6. So that means this nitrogen is going to have to give up its lone pair. So now we can all be complete. Just to show you, so there's 6 now, 2, 4, 6, and then each nitrogen have 2 up top. So they both have 8, and I was only able to use 10 of my valence electrons. 2, and then 6 here, 8, and then 10 with the last 2. That is how you do nitrogen gas. Hopefully you have everything you need to draw the rest. Remember, not all molecules need double, triple bonds, and hydrogen will never ever have a lone pair because hydrogen will always have a single bond, so it'll be full. So you'll never see an H with a dot because an H will always have a bond to it. That's a major misconception. That's the last thing. Thank you everyone for watching this video. Have a great day. Please take the 10 survey before you go. Bye.